Good day everyone, we will now solve for the air glider problem. Ready your pens and paper.
A glider was thrown at an angle of 57 degrees. The glider went up at a speed of 5 meters per second for 3 seconds and descended with a bearing of south 69 degrees east at 2 meters per second for 10 seconds. What is the distance from the highest point that the glider has reached perpendicular to the ground? How far is the glider from the starting point to the landing point? What is the angle of elevation of the landing point to the highest point?
Let us say that point A is the starting point of the glider. It is thrown upward 57 degrees from the ground at the rate of 5 meters per second for 3 seconds. Let us say that that point B is the highest point where the glider has reached. To get the distance from point A to point B, we must multiply 5 meters per second by 3 seconds. And that would be 15 meters. So the distance from point A to point B is 15 meters. Let us say that the landing point of the glider would be point C. The glider descends at the rate of 2 meters per second for 10 seconds. To get the distance from point B to point C, we have to multiply 2 meters per second by 10 seconds, and that would be 20 meters. So, from point B to point C, the distance is 20 meters. Since we have completed the triangle, we can now proceed to the first question of the problem, which is the distance from the highest point perpendicular to the ground. Since this is perpendicular to the ground, we can now form a right triangle here. And let us assume that this point would be point D. And from point B to point D, let us name it H. So let's just clean up the triangle and the solution. In order for us to get the value of H, we must first get the value of angle DBA. Since this is a right triangle, angle DBA would be complementary to angle DAB. For us to find angle DBA, so 90 degrees would be equal to angle DBA plus angle DAB. So let's transpose angle DBA would be equal to 90 degrees minus 57 degrees. So angle DBA is equals to 33 degrees. To find H, we will use the cosine function. So, cos theta would be equal to adjacent over hypotenuse. So, cos 33 degrees would be equal to the adjacent H over 15 meters. So, H would be equal to 15 cos 33 degrees. So, the value of H would be 12.58 meters. So now, let us proceed to the second question of the problem, which is the distance from the starting point to the landing point. For us to get the distance from the starting point to the landing point, we must first get the value of angle ABC. So to find the value of angle ABC, so that would be angle ABC would be equal to 33 degrees plus 69 degrees. And that would be angle ABC is equals to 102 degrees. Let us assume that from point A to point C would be distance B. So to find the distance B, we will use the sine law. So B over sine 102 degrees is equals to 20 meters over sine 57 degrees. So that B is equals to 20 sine 102 degrees over sine 57 degrees. And the value of B would be 23.33 meters. So now, we can now proceed to the last question of the problem, which is the angle of elevation from the landing point to the highest point, which is angle C. To find angle C, (180 degrees) would be equal to angle C plus angle A plus angle B. So 180 degrees is equals to angle C plus 57 degrees plus 102 degrees. So now angle C is equals to 180 degrees minus 57 degrees minus 102 degrees. And now the value of angle C would be 21 degrees. So now we have finished the problem. So that concludes the solution for the air glider problem. Thank you for watching and listening. We hope you learned something. God bless.